Hello! This video is a presentation to introduce the tender call, implementation of a multi-omics workflow to derive human reference points and health-based guidance values from quantitative in vitro data. The main background of this tender call is safety assessments. It is known that assays used in food and feed safety are still largely based on legacy endpoints and in vivo studies. This leads to a limited mechanistic understanding of the molecular mechanisms underlying toxicity or positive health claims. For this reason, new studies comprising the newest and most innovative techniques in safety assessment need to be performed. One of these techniques is OMICS. In OMICS assays, the complete response of a biological system to the exposure of a substance is measured in a single experiment. These assays have already proven to be extremely useful to inform on the molecular mechanisms of toxicity. For example, you can perform a transcriptomic study on the genes expressed in an organ, in this case, the liver. From this study, the relevant pathways can be inferred using bioinformatic approaches. Another one of these techniques is organ-on-chip. Organ-on-chip are in vitro systems based on microfluidics technology, capable to recreate a microenvironment of multiple interconnected organs, which was shown to faithfully recapitulate human physiology and pathology. The tender call is divided in two phases, Phase 1 and Phase 2. Phase 1 consists on a laboratory and a computational part. On the laboratory part, the applicant will need to select 6 to 12 data-rich substances and generate experimental omics organ-on-chip data. The computational part will consist on analyzing and testing state-of-the-art tools and coding a pipeline prototype for deriving reference points and mechanistic information. This pipeline will be applied to omics data in order to define a final experimental workflow for Phase 2. Phase 2 also consists on a laboratory and a computational part. On the laboratory part, the applicant will need to select a minimum of 25 data-poor substances and generate experimental omics organ-on-chip data. On the computational part, the applicant will need to apply the novel pipeline to the newly generated omics data to predict reference points and mechanistic information. Here are some important remarks to keep in mind when applying to the tender call. In vitro models, the main omics data must derive from organ-on-chip and no other in vitro models. Moreover, organ-on-chip should be based on microfluidics. The use of more than one organ in organ-on-chip is recommended and will be considered an asset. There is a possibility to include additional in vitro models, providing a very clear justification for the addition. Omics assays should include transcriptomics, metabolomics, and epigenomics. Other types of measurements can be included upon clear justification for the addition. If measurements other than omics are proposed, they should not constitute most of the experimental costs and should be clearly written in which way they will be analyzed in synergy with the omics data. Phase 1. Details on sampling and models. The tenderer is free to undertake any kind of experimental design. However, organ-on-chip must be part of the design and should be based on microfluidics. Moreover, the overall design must be fit for purpose. Epigenomics. It is recommended to use a direct readout of the chromatin status, such as ATAC-seq or ChIP-seq. It is especially preferable not to use microRNA because it is based on RNA-seq and redundant with the transcriptomics readout. Different technologies, when integrated, can give more robust signals and should be favored. Bioinformatics and cheminformatics analysis. Bioinformatics should play a central role in the characterization of substances. Cheminformatics analysis is likely required to derive or fine-tune values. Logical and step-by-step explanation of the joint use of bioinformatics and cheminformatics analysis must be provided. ADME analysis. Evaluation of absorption, distribution, metabolism, and excretion properties of compounds is a fundamental part of the hazard and risk assessment of chemicals. There should be a relevant in vitro in vivo extrapolation. It is important that if the tenderer intends to include ATME modeling, it must consider the organ-on-chip model physiological process. Here, we can see the quality-aware criteria used to evaluate the proposals. It should be noted that EFSA does a very structured assessment of each proposal and is very systematic in checking. For this reason, it is recommended to focus on all the points evaluated in order to pass the minimum threshold. There are 3 criteria evaluated in the proposals. The methodology proposed for implementation, with a maximum of 50 points and a minimum threshold of 60%. The project organization, with a maximum of 30 points and a minimum threshold of 60%. And the risk management, with a maximum of 20 points and a minimum threshold of 60%. Moreover, as seen in this slide, each criteria has a specific subset of aspects evaluated. For example, in the methodology proposed for implementation, up to 20 points are given if the tenderer correctly understands tasks and proposes a clear methodology.